homework. It's time to start our class. There it is. Here you go.
Get old Grammy's phone.
That's right. Grammy's old phone.
Get how it works. They're working right now.
Right there. Button. There you go.
It's working.
It's working. You want to say hi to my students for me? You can look up here and say hello. He's smiling. They can hear you. You can say hello. You can talk to them if you want.
I can push you.
Yeah, with me.
I can push you.
You know, I gotta start teaching soon. No. Oh look, we have a student awake. He said hi.
Hi.
There you go.
I can push you.
You want to take a picture with me? Alright, me and Samuel have to take a selfie real quick. Hold on, I gotta turn it around. Okay, Sammy, smile.
Cheese.
There you go, baby.
Don't
Oh, you want to look at it? There you go.
look at yes.
Yeah, that's us. That's me and you. Wow, your brothers are going crazy outside. It might be time for you to go play. You can go play with your brothers? Okay, well you can stay here. Alright. Welcome to, let's see, Tuesday, April 28th, office hours. Plans for today, I don't have a whole lot, no lecture or anything like that. But the only two things I need to cover are...
Dad, can I ask you this?
You want some of my coffee? Here. Uh-oh. Little spill, that's okay. Let's see, what were we talking about? I'm gonna go over exam 3 for dual credit. I'm not going to answer...
You put your phone in your pocket.
Well, let me put it over here. I'm not gonna put it in my pocket.
Like,
Well, you're sitting in my lap, that's why. Alright, let's see. We are going to go over the test. I can't give away every single answer. I actually have, due to, you know, doing the whole virtual school thing, there are a couple of students that need extra time on the test, which I am allowing. But I do know that some of you... I do know that some of you have questions on your grade. I did grade every test yesterday, so pre-cal and dual credit, everything should be completely graded by now. There were some questions. There's probably going to be some questions. I already got a couple of emails about why they got a particular grade. All the comments on your test, if there was anything specifically, I left it on the Google Classroom post. So I know you had it in 2 places. Blackboard, I need you to post it to Blackboard because mostly I need you to log into Blackboard to do the course evaluation this week. So I'm going to make that a big post on the Google Classroom. So please log into Blackboard, do your course evaluation. And the comments I left in the Google Classroom because it's way easier to do on there. Okay, so and then after that I had a question on the homework for pre-cal, and I'll do that too, just a quick one, and that one shouldn't take too long. And that's the plan for office hours today. Okay, so like I said, let me just talk about a few of these. I'm not going to work the entire thing. I'm not going to give away the answer to everything, but I will work enough of it to where if you know what you're talking about, then you should be able to get the rest of the answer from there. So that way the people that haven't taken the test yet, they won't just get a free 100, if that makes sense. Here, go. Here, take your phone. Go to Mama. Go play with Mama. Okay. Alright. Sammy, will you close the door? Oh, okay. All right. All right, so let me head over to this computer and let's do this test. So solve the triangle for number 1. Remember, you don't necessarily know whether you start with law of sines or law of cosines unless you pay attention to what info is given to you. Here you have a and a, so you should have begun with law of sines. So you have a over sine a equals b over sine b. And then so plugging in the numbers, you know it's 11 over sine of 37 equals 21 over sine b. You want to solve for the angle, so you cross multiply and divide, and then you end up with 11 sine b equals 21 sine 37. Divide this over, and then inverse sine, and that tells you what angle B is. And then, spoiler alert, you don't have to go any further in this problem for some strange reason. All right, part B. Same thing. You set up law of sines. Now you have B over sine B equals C over sine C. There you end up getting C equal to something like 59.7, something like that. You do have ambiguous case on this one, so I will tell you. You do have 2 cases in this problem. You should have solved both triangles. And other than that, I'm not going to spoil too much there. The setup is almost exactly like this, except you actually keep going. Okay. Number 2. A really common mistake I saw on part A was that I asked you for the magnitude of 3u minus 2v, and y'all just gave me 3u minus 2v. So here, you've got to figure out what 3u is. So that's 6i minus 12j. You've got to figure out what 2v is. That's negative 6i minus 4j. And then so if you do 3u minus 2v, you get 6i minus 12j minus negative 6i minus 4j. And that negative distributes. So you're adding a 6i and you're adding a 4j. So you should have eventually gotten 12i minus 8j. That's not the answer, which I think a solid half of you stopped here. You have to find the magnitude of this. So you've got to do Pythagorean theorem with 12 and 8. You eventually get a square root of something, and then if you need to reduce it, you should reduce it. Which, by the way, you should. This one you do reduce. Here you don't have to mess with vectors, but you do need to find the magnitude and direction. So just like earlier, do Pythagorean theorem with 2 and 8. Get the magnitude. The direction angle, and this is something else, I would say like more than 50% of you missed. I want to say somewhere close to 70 to 80%. What quadrant is 2i minus 8j? Over 2, down 8. Right? So that's 2i minus 8j. What is the angle I'm trying to find? Here's 0 degrees. That's the angle. So when you do inverse tangent, and then opposite should have been 8, adjacent should have been 2, you get that angle whatever it is, and then you should have done 360 minus whatever that was. I'd say maybe 8 people got it correct out of all of you, out of all 55 of you. So. Yeah, so that one got a lot of you on the angle part of that problem. Oh, wait. Here we go. Hello, come on. Switch pages. Oh, I gotta use my mouse. Maybe? Oh, that's the same page. Oops. Okay, number 3. You are on a basketball court practicing free throws. The free throw line is 15 feet away. You are 6 feet tall and the basket is 10 feet off the ground. So that means there's a difference of 4 feet. So if you've got a person here, oh, whoops. If you've got a person here, you've got a oh, I did not draw this to scale. Whatever. I'm going into the wording. So that's 15 feet. This is a difference of 4 feet. And I want to know the angle that I look up. You have the opposite and adjacent side, so you should have done tangent with 4 and 15. Part B is the same thing, except you just get closer. So now you're right under the basket. And now this is 2 instead of 15, but this is still 4. Right, you haven't gotten any taller, the basket hasn't gotten any taller. The distance between you two. And then the last part of this, how much has your angle of elevation changed? Not just what is your new angle of elevation, how much did it change from the previous part? So whatever your answer is here, you're supposed to subtract the answer you got from part A. If you notice me highlighting the word changed on a lot of your papers, it's because you missed that part. Okay. Alright, polar coordinates here. I mean, most of you got this just fine. I'm not too worried about this one. So 4, 175 would have been in quadrant 2, because here's 175. And then you go 4 spaces out. So you're somewhere in quadrant 2. And then part 2, part 3, part 4. I mean, like I said, not too many people missed it, so I'm not worried about this one. Part B. There's not too many ways I can discuss these without giving away the answer, so it's a little bit tricky. But I'll give you, I guess, the first step, and then I'll talk you a little bit, just through what your mentality should be for the rest of it. Part 1. There's a few ways you can do it. You can replace x and y with r sine and r cosine, and you eventually get to the right answer. I think the easiest way to begin the problem is just add x squared over. And now you've got substitutions to make, and instead of doing r sine and r cosine for everything, you've got a direct substitution for that, which should make the problem a lot shorter. It was supposed to be a very short problem. So, oh yeah, I don't know, maybe y'all were helping each other or something. I mean, and I'm not upset at that, by the way. I expected that to happen. But there were a solid 20 of you that just did not show me any work on part 1 of this problem for some reason. There's no logical way you jump straight from this to the answer, if that makes sense. So just writing the answer on this was not sufficient. You didn't get any points on that. So for those of you that did that, shame on you. Remember, there's always the disclaimer. If you run out of work must be shown for full credit. There we go. Okay. Oh, and then part B, convert the polar equation. The key to starting this problem is recognizing that secant is over cosine. And then you should be able to finish the problem from there. All right, number 5 is another one of these solving problems, and as you could have expected, one of these problems was law of sines, one of these problems was law of cosines. So for number 5, you're given 3 sides. You had to do law of cosines here, and you had to find all 3 angles. Because you have to do law of cosines, you do not have to check ambiguous case, because law of cosines never gives you ambiguous case. Right. So don't even worry about a second triangle. Even though the instructions say something, I just copy pasted whatever the instructions were for number 1. Second triangle can't exist with these measures. So you just get your answers there. And then part B, for the triangles in part A, which is just 1, find the area of the triangle, and here you just use Heron's formula. Okay. Number 6, determine the exact scalars such that the vectors are orthogonal. Orthogonal implies that v dot w is 0. So just take the dot product, set it equal to 0. C should be the variable in the problem. Solve for it. Part B, find the angle between the vectors, and here you're supposed to use v dot w equals magnitude of v times magnitude of w times cosine theta. And theta is the variable. You should have all the information for the other one. For everything else, you can find that because you're given the numbers. You can find that Pythagorean theorem. You can find that Pythagorean theorem. So that's pretty much the main body of the whole test. Let's talk about the bonus, I guess. Again, I'm not going to give too much away, but there were two main parts of this that I was checking for. Number 1 was a correct graph, and number 2 was the equation of the combined parametric. So it gave you a little spiel about what a parametric was. The only way really to do this problem was to solve y for t. So take that second equation, solve it for t, plug it back into the one for x, and then you should have had, I told you in the instructions, one equation of x in terms of y. So that should imply that x equals something, and there's a bunch of y's in here. So you do that, and then you end up graphing. And the chart helps you, but the chart I didn't really grade. You're supposed to graph something on here. And because it's x in terms of y, you know things are going to go sideways. Whoops. You know things are going to go sideways. And the main characteristics I was looking for is you listed coordinate points for me, and you drew the entire thing, which implies the, not to spoil anything, but there's a certain part of it that some of you that attempted this problem, y'all did not get. So I will leave it at that. Okay, so that's the test. So those of you that emailed me, hopefully that helped. If it didn't help, then please email me again if you have a specific question, because if I'm emailing you privately, I can discuss answers and all that stuff with you. I'll let you know what the actual correct answer is. I'll let you know what you need. But again, I'm not going to spoil any of that till after the final exam is done, just because we've got a couple of people with excuses for turning things in late, just because, any decent teacher is going to give a little grace since we're kind of transitioning to this online stuff. Okay. Well, I would have done a Twitch drop at this point, but everyone logged in has already won one. So, I guess I can't. Ruth. Okay, Ruth, let me, I'll address all of your points in order, okay? So checkpoint number 4 was the one that you solved the exponential equation, right? Here, let me just open the PowerPoint. I'll tell you what I mean, because that's a good question. We should cover it. Because your final paper is due tomorrow, and that's whenever I'm actually going to use the rubric. Okay, there we go. Okay, so I'm all set up. Now, just to remind you, tomorrow is not your final draft. Tomorrow is when you put everything together, you write your conclusion. You're turning in your rough draft to me. I'm not going to give you your final grade on anything until you give your presentation, which is going to be next Tuesday. Okay. Oh, by the way, we're probably going to have an assistant principal or two sitting in on the Zoom meeting because they're all really curious about what we're doing. So it's not just going to be me. They're not going to talk or anything, but we will have spectators. Okay. So yeah, the thing you're turning in tomorrow, your paper and your presentation, are rough drafts. That way I can give you feedback before you do your actual presentation next Tuesday, and that's when you're going to finally get graded on everything. Because I'm going to ask you to resubmit your final paper afterwards. Does that make sense? Okay. So, when you say to show your work in the traditional math setting, how exactly would we do that? So you should have looked up an online source to try to figure out, when your initial case was. Wow, Atarv, that's not how you spell stalkers. Okay, so sorry, I had to fix that. So the equation I told you to use is your traditional exponential growth equation. A times P to times E to the RT. So you should have tried to look up an initial case, when it was, and then a current case load. Right now, I mean, the U.S. has exceeded 1 million at this point, but just whatever date you use for an endpoint. So you need to look up a final amount, you need to look up an initial amount, and you need to calculate the amount of time. So time being days, probably, for y'all. Right? I would not keep this in years. So let's say, I'm just going to throw out numbers. These are not scientifically backed or anything, but let's say your first case was like February something. February 28th. We'll keep it simple. We'll do 2 months. February 28th, and you have 50 cases. And then now you have 1 million cases. And then the time between February 28th and now is 2 months. I guess March was only 30 days. So we're just going to say 60, even though that's not right, but whatever. So this is going to be an exponential growth rate in terms of days. If I want to see work, I need to see all of this. I mean, some people did it as an image file because they wanted to do their own, actual work. Okay. I need to see all this. So hopefully that's... Does that make sense, Ruth? So I want to do all of that, get that decimal, figure out R is going to be some decimal here. And then you have to do the problem again. And then now you have to set A equal to half of the US population, which is roughly 150 million. Say 150 million, yeah. And you're still using 50 as your initial, and now you have R. And you're solving for time. And then again, just like you did in the first part, I need to see all the work to solve for time. So that's how you show me all of your work for the traditional math. And the written explanation of the work, I remember now y'all's paper. It's fine, but this is what I really wanted. So talking your way through it with words is okay, but it's a little verbose. Kind of like how, I don't know, I'm not an English teacher, so I don't want to talk about how you write essays, but kind of like how if you ever have to hit a word count, then you try to like fluff it up with things from the thesaurus, and you try to make your sentences run on a little longer than you normally would, things like that. That's what your paper sounded like whenever you explained all of this with words instead of just with the math. So if you need to, just do what I did, just make a PowerPoint and then save it as an image file, like use Paint or something like that, and then copy paste it as an image into your paper, or annotate directly into the paper. You can do that as well. Whatever is easier for you. You're at the point now, you're getting to the end of the paper. I don't want formatting issues to be the stressor, whatever, for this. So let's see, let me keep going through your questions. So yeah, long story short, I don't need a written explanation of the work if you are showing me this, because this is a much cleaner way to do it. Research paper for checkpoint 5. No, I want all of your checkpoints combined into a single document. So the thing you turn in on checkpoint 5 is your final paper. It's a rough draft, but it's your final paper. So from top to bottom, it should follow the outline that I gave you on the first post. And I also need your presentation, your PowerPoint or whatever, any graphics you decide to include. And it should be an excerpt of your paper. I mean, I'm not going to tell you have to condense anything. You should make it readable, and you should make it neat, and you should make sure it meets all of the things on the outline I told you to. I'm not grading anything based on how long the paper is or how nice you make things. I just wanted to have all of the correct relevant data. Part of your grade is your presentation, though. So if your presentation isn't as neat and concise as it can be, you might not get full marks for people, actually participating in your presentation, because you're probably going to bore someone by making it too long or too wordy. So I hope that answered your question. I don't have a specific thing on condensing it or making it a certain length or that, but you should make it as neat as possible so that people actually pay attention, because part of your grade is your presentation. All right, I think I answered all your questions. Yeah, and I'll give you feedback on the paper before next Tuesday. So you're going to turn it in tomorrow. I'll let you know in a private comment, just like I have been, what I think you should fix before you turn it in for real. And I might rename the actual post on the Google Classroom to say rough draft so that people get the idea. But it is just a rough draft tomorrow. Okay, I think the last thing I had to talk about today was I just had a homework question from pre-cal, from high school pre-cal. So let's hop over there. So y'all have a homework due tomorrow. Whoa. Hold on. Here we go, okay. And it was something really similar to number 6. Let me just do number 6, I guess. So negative square root of 2 over 2 equals sine of negative 3 theta. Okay, so the sine is already by itself. There are no outside steps to take. So the first thing you need to do is look up on your trig chart or look up on your unit circle, where is sine equal to negative square root of 2 over 2. So that means that negative 3 theta is going to be equal to, now on your unit circle, that would have been this spot and this spot. That's where the y coordinate is negative square root of 2 over 2. So the first time that happens is 225 degrees. Next time it happens is over here at 315. And then I would always go one more, because you're going to end up dividing by 3, so they're going to all get smaller. So I would add 360 to both of these. So 585, 675. And I don't think 800. Actually, would 800 fit in there? I don't know. Let's just get these answers first. Divide everything by negative 3. Oh, I see how annoying this is now. Because you're dividing by negative 3, all of these become negative, which is going to make all of them less than 0, which is not going to fit the numbers that you want. So you actually don't want these. Instead of adding 360, I need to subtract 360. Because remember, you're allowed to go either direction. I want it to originally be negative so that when I divide a negative, it'll become positive. So this is, negative 45, negative 135. I guess we should keep going, huh? Negative 405, negative 495. So those are the numbers you divide by negative 3. So you should end up with, 15, 45. This is 135. 1. What is this? 665. And then you're going to have to go a few more because you need all the answers from 0 to 360. I'm assuming this is probably one that has a bunch of answers because you're dividing by 3. I mean, you can check the answer key for them, but yeah, see, we should have gone further. We should have gone 2 more. But to address that question on the homework, that's why. So, because you're dividing by negative 3, you wanted negative answers, and then dividing the negative brings you back into the positive range. Okay, I think that covers everything I wanted to talk about today. Just to remind you what's on the schedule, tomorrow we have a pre-cal lecture. So high school pre-cal kids, tune in for a lecture tomorrow. We're going to talk about polar coordinates. I'm going to teach you what that is. A little prep for calculus if you're going to take that after this class. Dual credit, please log into Blackboard and do your course evaluation. They are really, really badgering us to make sure our students do that this semester, especially with all the online stuff going on. Extra credit checkpoint number 5 tomorrow. And then dual credit, you have a final exam next week. So things rapidly coming to a close for the school year. Okay. Yeah. No Twitch drops today. Everyone that's logged in has gotten one. So, all right. I will see y'all tomorrow.